I would like to start today by discussing one part of the homework that you had. Page number 161 mein you were to do two delta H's. One you would need Hess cycle to solve, and the other you would need bond energies to solve, right? Part A was Hess cycle, and everybody can draw this stuff. Part B was bond energy. And there were two ways of solving this question as bond energies. One was simply stating delta H is first bonds broken minus enthalpy of bonds formed, and then you are to write all the bonds that are broken. How many bonds are broken? Four of CH bonds are broken, and one of I is broken. And what is formed? 3 CH, 1 CI, and 1 HI. Now you could add all of these values here, brackets mein, minus all of these values here, and solve for delta H, and you do that, you get plus 12, plus 22. Take it. Now, but one thing that you will need in for later practices, especially when you have a lot of the same bonds being broken and formed, is that you can simplify a calculation. Because here you know you're breaking 4 CH bonds, but you're also forming the 3 of them again, same value. So instead of doing this, you can say the net value that you would need to worry about is that you're really only mainly breaking one CH bond. So we can break one CH bond and one II bond and then form one CI and one HI. So that would make the math a little shorter and easier and less chance of errors. That's the first thing I want to talk about. So CH ki value thi 430? 410. II is minus, CI is, and HI is, and this will also give you plus kilojoules per mole. Okay? That's the first thing I want to talk about in this question. How to simplify life in these questions. Second is the idea that you will see a lot of questions that have the term suggest. When you see this in a question, please understand it is something that you have to think outside of what you know, or at least what the syllabus explicitly says. Now when you've done, they're asking why this does not occur. While I were to scroll up right here, this reaction we know occurs because we've done this in free radical substitution. And then it says this reaction does not take place, but find the theoretical value of the reaction. When I look at this value is plus 22. And then after doing both the parts, now they're saying, tell me why this doesn't take place. And so it will be to compare this with the previous reaction. If you look at the previous reaction, the value was minus what? 99. And this one is plus 22. So it must be to do with the fact that this is endothermic. And why does this not take place? Because this reaction is endothermic and will need a constant supply of energy. So when they say why doesn't it take place, it means they don't take place in the normal conditions, that you can start the reaction and it will happen on its own. It won't happen on its own. It will have to be continuously be heated for it to take place. So that is the one reason why. It does not say that every endothermic reaction doesn't take place, but you will realize if a reaction doesn't take place, it is generally endothermic. And the complete reason why you will do in second year. In the first year, you need to know that most exo take place and most endo don't take place. Because the endos will require a continuous supply of energy. That's why they don't take place. Okay? And so you write that here, and that's the answer for this part. Sad part is in AS level, maybe 2 or 3 marks in the whole paper are suggest. But in second year, every question has at least 2-3 marks which are suggest, every question. So 20 to 30 marks of the paper are suggest questions, which is the most beautiful thing in second year, because you got to use this. Anyways, that was me showing my appreciation for the next year. Okay, getting back here. So ye ho gaya, samajh aa gaya? Now I want to talk about one other way of solving bond energy questions before we finish the chapter. I know there are a couple of slides left and we'll talk about them, but one more thing I want to talk about here is this. That can I change this? Okay. Now, instead of, there's one way of using delta H is equal to bonds broken minus bonds formed. The other way is, let's talk about the other reaction that was shown to you. वो क्या था? CH4 plus Cl2 becoming what? CH3 plus HCl. Now, one way is to do it in terms of bond breaking minus bond forming. बिल्कुल possible है. You can also apply a Hess cycle to this, where the reaction that is given to you to be found the value of delta H, you put them in boxes A and B. ये A हो गया, ये B हो गया. And obviously you need a third box, C. Now, if you were given delta H formations, you knew the third box would be for elements. You were given combustion only, then you would realize the third box would be for combustion products. And if you are given bond energies to use only, please remember what bond energy by definition meant. It meant the energy required to break 1 mole of gaseous bonds to form what? Gaseous atoms. So what you'll realize is whatever bonds you have, when you break them, you will form what? Gaseous atoms. So the third box will become gaseous atoms. Now what I mean is, if I were to break 4 CH bonds, what would I make? If I broke these 4 bonds, मुझे क्या मिलेगा? I will get 1 carbon atom and 4 hydrogen atoms. Bond breaking only is energy required to break the bond into 8 gaseous atoms. Then if I break Cl2, what would I get? Now, so before I do that, so this arrow from CH4 to this would be the 4 C8 bond breaking energy. And then I want to break one more Cl2. And that would give me what? 2 Cl atoms. And this value would be the Cl bond energy. And instead of making these molecules, I can also break them. What if I were to break all these bonds? तो क्या मिलेगा मुझे? 1 C, 3 H's and 1 Cl. 1 C, 3 of the 4 H's and 1 of the 2 Cl's. And if I break this bond, I will get 1 more H and 1 more. So I will get 4 H's and 2. So I will do this also. कि यहाँ से this and this together will give me the same atoms. And breaking of this arrow would be what energy? It would be 3 CH bonds and 1 CCl bond. And this would be 1 HCl. And this arrow is the one I do not know, so I call that X. Now in this regards, what is my start box? A. And what is my end box? C. So I can go from A to B to C, or I can directly go from A to. So what is A to B? X. And B to C is 3 times CH, 1 times CCl and 1 times HCl. Now all of these values are bond breaking. They all arrows are pointing towards atoms. That means all of these values are going to be positive. And what are the values for A to C? 4 CH bonds and then 1 Cl bond. Yes, you can simplify them here, but that's the thing. You can if you want to. And then you plug in the values and you simplify. यहाँ 3 हैं, यहाँ 4 हैं. So 3x and 4, variable ले लो उसको, तो this becomes 1 CH bond left. Right? So X plus CCl. CCl की energy क्या थी? 3. What is CCl की bond energy? Somebody tell me from the data booklet. I'm not solving it the way you will. I'm saying if this question was given to solve with bond energies, तो क्या answer आता? And HCl की क्या value है? 4. ठीक है. And 1 CH की क्या है? 410. And 1 Cl की कितनी है? 242. And that's it. So all positive. When you solve for X, you will get X plus whatever this is, 771 is equal to 650. And you get what? -1. Yeah? I mean, this is just rough workings here. So that, I mean, why the answer is different, we'll talk about that in a second. But my point was that you could use Hess cycle to solve the same question using bond energies. इसमें क्या है? There is no minus. It's all bond breaking. Cut, cut, cut. Everything becoming gaseous atoms. I don't care if you don't ever use this. I do care that you appreciate how this works, because they can give you a question like this. कि ये बना के दे दिया, अब बताए मुझे क्या हो रहा है. So you should be able to draw this. Now, the second thing you'll notice here is the value here is not the same as the value that you have. And the reason, simple reason is, why? These values come from average values. So these are average values of CH bonds, not specific to this molecule. So average values will only give you an approximate answer. So you have to say average values, not approximate values, average values.